Okay, do we have any sound? Oh, hey, there's some audio showing up now. Any sound? Oh, there's some audio showing up. All right, so I think we've got audio. All right, so I think we've got audio. First time streaming, so we're learning as we go. Okay, so we kind of missed the introduction, so maybe we should go back and cover that. So what we are doing today, we are assembling and going through how to safely solder for the first time. And there is what we're assembling is a Bluetooth speaker kit.
That I got for Christmas from my dad. Um, so this is the case is right here in acrylic, and then here are the speakers, and then here's the board, all brand spanking new. My iron or my soldering iron,
That was also a present from
also
someone.
a present, and then my dad's soldering iron came with a remote because I'm pretty sure it has lights too. Back panel, I think.
So that's got on the front panel. It's got infrared
Infrared
and a USB port.
and a USB port. Yep.
Cool. And then a bag of parts.
Bag of parts and screws, yeah.
All right.
And then this also came with it. It's a wire, I'm guessing, for that we're gonna attach something. And yeah.
All right. And there was one audio kit instruction sheet, which has a bill of materials of all the parts. And basically, we've got some electrolytic capacitors, a triode, integrated circuit, switch, a light emitting diode, adjustable resistor, a microphone, USB line, two horn speakers, a Bluetooth module, remote control case, and screws and nuts, and the circuit board itself. So,
circuit board. And not sponsored, but if you want to get yourself one of these, it's a San Urigo 7H72 soldering iron. Here's the front. And then there's that. And then there's that. And the assembly is like this. So okay, so it comes in screwed all the way in like this. Hold on. Comes in like this. Screwed in. Whoops. And in this part as well, this is the soldering tip. Then you unscrew it. Put this down. Put the white part in first till you can't push it in anymore, but don't force it. It could break. Very careful with soldering irons. And then you put this on. And you cannot use this for anything but soldering. It's not for anything else.
all right. So what we're going to want to do first is to make sure you've got your tip, because you can turn your tip. Just want to have it kind of pointed so it's comfortable for you to hold the soldering iron. That soldering iron has an adjustable temperature knob, it looks like.
Adjustable temperature right there. And this is the port for it.
Yep.
It does not come with the port.
It has a DC barrel adapter, which is labeled 12 to 24 volts. So my guess is, depending on how many volts you have, the more power you have.
12 to 24 volts. That's what this says.
Yep. So we've got
DC 5525.
Great.
12 to 24 volts.
So we have a barrel connector DC.
Hi, Shadow.
This is from a laptop or a thin client charger. It was 19 volts, 3.42 amps. So this should be just fine. I believe it will fit. It does. It's a little LED that lights up inside this
Let's
guy.
see.
And it's already starting to smoke. So it heats up pretty quick.
It's nice.
All right. So here you go, Lucian.
I think
And-
first we get the parts out though.
Yeah, and we need like a little bit of a stand for you, for that to go on.
Hold on.
So your
I have something, I think.
soldering iron can sit safely.
Don't have my thing from my wood burner, but we have this. I mean, it works. If you want to use it.
That could work.
Just an idea.
Sure.
A little heavy. It's a little on the heavy side, but it works. I think. Yeah, that's
I
probably
think if we
good.
do it like that, you can just kind of set that just to keep your tip
Yeah.
from touching anything and burning,
Right.
melting through this plastic desk or anything like that. Got a silicone mat here as well as on top of wood. So we should be pretty safe from any heat.
Looks like we have 10 batteries.
10 batteries. What do you mean?
Or 10 what are those?
Okay, so let's go over first of all what we're going to be doing here. So the circuit board is where most of the components will go, and all of our soldering goes. There is another little circuit board on the input for this, but it has connectors that will connect it to the
Okay,
motherboard.
I don't
So
think those are
won't be any
batteries.
soldering here.
Yeah, those aren't batteries because they say D, not.
Right. So let's go over what these different labels mean, because circuit boards, they're not just random names and stuff on things.
Right.
So if you take a look at it, and probably don't need the magnifying glass, but the light's very helpful. Generally, you will see very common names and letter conventions on things. So D on a circuit board stands for diode. Okay.
Diode, right.
And there are different types of diodes, a lot of different types of diodes. In this case, D1 through D10, here all in a row, is for the light emitting diodes, the LEDs.
Ooh.
Okay. So these are diodes that will light up when they get voltage applied to them. It is very important. There's a plus and a minus marked on every one. Diodes have to go in one direction because what they do is they only allow electricity to flow in one direction. If you
That's right.
wire them backwards, they just will, worst case, blow up or burn out. But best case is just they won't work and you have to turn them around. But we want to make sure we get them in correct. Those,
especially the first time where you're gonna have to somehow desolder them all at once.
absolutely. So thankfully, the silk screening on the board is marked with the plus and the minus,
Right.
for the anode and the cathode. You'll also see markings that say R on them.
Those?
And these numbers don't mean anything except that they denote which part goes to. So they will line up with the number. They'll line up with the number that's on your component list.
Mm-hmm.
So like number 1 on the component list. R1 here is the tag number.
Resistor.
So the tag. So if you look, the tag number says R1. So you'll find R1 on the board.
And it's a resistor.
20K resistor. Yes. So R stands for resistor.
C right here.
C will mean capacitor.
Capacitor, yep.
And those also generally will have a plus and a minus. They only go one direction. Those, if
or
you go
a
the
plus
opposite
and
direction,
a couple lines in this case.
Yeah, if you don't get those in the right direction, they can explode.
Yeah, and probably will.
And that would ruin your day.
Yeah.
As well as your project. You just generally mean some sort of microprocessor or multi-pin chip. So it's some sort of chip, silicon chip. Your VCC is going to be your voltage input. In this case, it's 5 volts. And I know that because it says It's powered by 5 volts.
And there's also a continued list on the back of the parts.
Yep. And then ground, G and D, will be
Obvious.
labeled there. So I think that's pretty much all we have. Oh, we also have Q. I forget exactly what Q stands for.
We also have CD 4017.
Yes, and I believe that is the name of the part. That is U1.
Ah,
That might be the chip identifier, and that'll probably be listed on
okay.
the chip itself. You also have the variable voltage resistor. It's called a potentiometer.
The UR1.
What's, this is where it's labeled VR1. Variable
VR1.
resistor 1, and it says 10K, so it goes from 0 ohms up to 10 kilo ohms. And there's a little screw that allows you to adjust that. Okay. I think that's it. So you'll see like R1 here, next to R1 it says 20K. Next to R2 is 1.5 M per mega ohm. So those are the resistant values there. R3 is labeled 10K. R4 is labeled 470 ohms. So very useful markings. Of course, there's also some Chinese, which I can't read, marked on it. On the back, you've just got the through hole pads. That's where we're going to be doing the soldering. It's on the back side. There's the exposed.
This is all
exposed
through
copper.
hole. This is for through hole is mainly for beginners and maybe some bigger capacitors. And
Yeah, it should
what's
be.
the other type? Just like on board.
So stuff that is surface mount.
Surface mount.
It's called SMD or SMT sometimes. They're different, slightly different layouts. But yes, this through hole should be. It's very beginner friendly. It's pretty easy to do.
We should talk about what this is.
All right, talk about it.
What is this, bronze?
That is that there, I believe, is copper. Some of them are bronze.
Okay, so some of these are bronze, but we believe this one is copper. It's for welding head cleaning, so it's for cleaning this part. I don't want to touch it just in case it's still hot because it heated up pretty quickly. So it's for the top part of it, the middle part.
The tip.
Sorry. And then that's what it looks like, and I don't know if you can see any of that, but you can zoom in if you want to. I'm gonna hold it there for a little bit, but that's what it looks like. And then we have a 3D printer, so we 3D printed a case, or not necessarily a case, but a roll thing for it. But that's solder. It's bendable.
2 different thicknesses.
This is thicker and this is thinner. Do 2 different thicknesses, which is always good to have.
So here we'll be using leaded solder. Both of these are leaded solder, which means it contains lead. You this is true for anything solder related, but you want to always use a fume extractor of some sort to blow the fumes away from you. You don't want to inhale the smoke rising out of solder.
But that's why, if you have a fan and that's the only thing you use, I would get a small fan, and you want to angle it away from the smoke so it sucks it in instead of blowing it towards you. It's always a good tip.
Absolutely. This happens to be it's got a lithium-ion battery, so it's powered, which is nice. You can charge it up, and then there's not another cable that's getting in your way. It's also variable speed. I plan on building a fume extractor, which I'll probably cover in the future, with some carbon filters to help to clean the air as it goes through there too.
Okay, and then this is a 3D printed vise, and that's all the parts we have right now.
Yep.
And of course our dog.
All right.
Our cute dog.
So we're gonna try to get these parts out in a way that's not gonna be
Super.
totally messy and stuff.
Yeah.
We're going to separate those out. We can leave the speakers will be towards the end, so we'll do that later. Let's just get all the wires separate for now. So connectors that will connect to the other board. When you are doing through-hole soldering, you want to make sure to you'll place your parts, and then you will flip it over to do the soldering. You always want to start with the lowest height components first. That way,
and then that's the other side. You want to flip it over that, and you do the soldering on this side.
So the lowest height components, the reason why you do that is because then just when it's facing down, if you have higher components, then some of the lower components won't stay exactly where you want them to.
Right.
So we'll go through that here. So the lowest height components here are going to be our resistors. Okay, so we're gonna do that.
Looks like this
first.
is a resistor.
Nope, that's a capacitor.
That's a capacitor.
All right.
Okay.
So
I think resistors look like this.
You think?
I believe so.
Okay.
Right?
You are correct. Those are resistors.
I was wrong the first time, but these are resistors.
Yep. And what you will see is there's multiple bands across the package of the resistor. Those bands indicate what value the resistor is. Okay.
This one looks like it has 5, I think.
Probably. Yes. So there's 4 that indicate the value of the resistor, and then the 5th marking there is the variance. So it's like the quality, basically. It could be 5% plus or minus, or 10% plus or minus for the value. All of those colors mean something.
Like, these two are different. This one has some colors, some different colors, and this one has some different colors. Yep. They're all different.
In this case, we have 4 resistors. So let's find all the 4 resistors. I am very pleasantly surprised, and it's very nice to note that this component list actually in the remarks section lists the colors of the bands. So
that is remarkably nice. That is amazing.
Very helpful. We are also going, because I don't trust instructions anyway.
Not always, at least.
This could not be correct. So we're going to actually use a multimeter to measure the resistance value. So what we're going to try to find first is the 20K, 20 kilo ohm resistor. That should be marked red, black, black, red, and then brown.
Okay. That's no red. What is it supposed to read? From left to right?
Red, black, black, red, brown.
Red, green, brown, green. Wait, okay, read it again.
Red, black, black, red, brown.
Here it is.
All right, so we're going to put our leads here on it and measure. And we have 20.12 kilo ohms.
Nice.
Listed. So this is the correct one. They marked it correct. Resistors can go in either direction, so it doesn't matter which way this goes. But that's R1, so you're going to find R1, 20K.
R1 is right here.
That's it. So you'll see it either side of that. There'll be a little tiny hole. You're going to bend your leads.
That much?
And the hole's really close. So kind of what you want to do is to bend it really close.
Okay.
Like that. Kind of make a little, just a 90-degree tilt to it, and then you're going to work both of those into those 2 holes on either side of R1. It don't have to be perfectly straight. Just get them lined up and get them in, and then push it through until it's flush. Okay.
Flush.
All right. So when it's flush to the board, on the other side, you're just going to bend those legs. They're called legs. You don't have to bend them 90 degrees, but just bend them a little bit out, which will help keep them in position. Okay.
Okay.
So that'll help to keep it from falling out, which is their main goal here. All right. So you can flip it back over. We're going to find the next resistor.
Okay.
Okay.
I'm gonna pick
So
one.
R2, you see where R2 is?
I don't know if this one is R2.
All right. Well, R2 is 1.5 mega ohms. It's brown, green, black, yellow, brown. You should have brown on either side and then green, black, and yellow.
Yep. This is it.
All right. Let's measure it.
One on and then the other. You never, if something has even a little bit of power, you never want to touch it.
Also correct. You got 1.5 mega ohms.
Yep.
All right. There you go.
Okay.
So that's going to go to R2.
Oh, gosh. Shoot. Got it.
Good eyes.
Yep. Okay. So we're going to bend it a little bit. Cut the thing. Okay, bent. Bent. Okay, and now we're gonna find R2. Okay. And we're gonna put it in. Then we're gonna bend it a bit. Just a little bit. Wait, didn't bend that enough. So it's not to stay in. Okay, now it should stay in. Okay.
Okay, next up we
Two
have a
resistors in.
10 kilo ohm, which is this one here. It's brown, black, black, red, brown. If you want to double check the colors on there.
What is it?
Brown, black, black, red, brown.
Yep. That's it?
Yep.
They marked it correctly.
So that goes on R3, which is down at the bottom of the board next to U1.
Okay. Sorry if our dog is snoring a little bit. She snores really loud. Okay, it's in. It needs to be bent a little bit more. There we go. Okay, now we bend it. Bent these a little too much. Hold on, let me fix something. Just a little bend. Maybe we can bend it back up when we need to solve them.
Next one is 470 ohms. That's reading perfectly. That's R4.
Okay.
All right, so how's our board look now?
So it looks okay. Looks good.
Good. Well, up here, got the 4 resistors placed. Get that to focus here. 4 resistors placed. Like I said, the back, you bend the legs out a little bit so that they don't fall out. Just helps you when you're soldering. And now since those are the same height, we can just flip the board completely over and it lays flat, which gives us very good clean access to solder with.
Okay.
All right. Now with the soldering iron, we're going to want the temperature set about 350 degrees. That's 350 degrees Celsius, which is really hot, over 600 degrees Fahrenheit. So
Dad,
it will burn you very quickly. Yes.
it's not. I think it's stuck because it's supposed to go all the way around here.
No, it point that where this line is
Oh.
the temperature it's going to be at. So find 350. Okay, so it starts at 200 and the last marking is at 420. So right there, looks like 350.
Okay,
That's
we're
about
gonna
right.
plug it in.
Yep.
Wait.
And I would recommend using the smaller solder here. These aren't going to take a whole lot, but also just use more of it. Just allows you to control the flow a little bit better.
Should we cut them first or?
No, what we'll do is after we solder the joints, then we will trim the legs off of there. But first, what I want you to do is since this is the first time we've used this tip, we're going to tin the tip. Okay. So we're not doing anything with a board right now. Just get you're not going to need the magnifying glass for this board.
Yeah,
anyway.
I am. I want to.
Okay.
Just so I don't mess up.
So you're going to tin the tip. What we're going to do there, would you like me to show you first or talk you through it?
Talk me through it.
Okay. So what you're going to want to do is to melt some solder onto the tip. And we want to get solder all the way over. You see that kind of discolored part of the tip that's not shiny?
Yeah.
We want to basically get solder everywhere there, just to kind of get a coating of solder over it. All right. Let's turn the fan on. You want to work somewhat close to the fan. There you go. I'll work a lot of that on. For this part, it might help to use the larger diameter solder. Exactly the same. Just allows you to get more on without you go so far down. All right, that's a pretty full solder right now. It's starting to drip. Just want to push that in there, which will help to kind of pull it off. There you go. All right. How about on the bottom of that? I think you need to get a little more. Yeah, the flat part of the soldering tip thing. Just get that good and coated. There you go. Awesome.
Take the fumes out
And most of the fumes isn't the solder itself, but inside the solder is what's called rosin, which helps to deoxidize the material and helps the solder flow better. It really is a solder helper. The spool here. All right, so what you're going to want to do now is to get a little bit on your tip. Okay, melt a little on your tip. All right, and then you're going to want to heat up both the leg of the resistor and the pad on the board at the same time. Okay, and then push your solder towards the iron, and it should go down to the pad. Okay. There you go.
good.
It got on the pad. What we'll want to do in a second is to refill that. Get the flat part of your iron towards the
Like that.
towards where you want to heat up. Yep. It can sometimes be helpful to turn the board, make it easier to line up. There you go. Heat up both of those together and get your solder ready.
There we go.
Okay, good job.
Okay.
Good job. Now, what I see here on this is, if you look under the right under the magnifying glass here, go ahead and put your soldering iron. It's not going to burn anyone. There you go. You want to have kind of a Hershey Kiss-like appearance to things, right? What you got there, so you got enough solder coming up. It's coming rising up the leg there. This one looks like it actually might be a little too much, or it just didn't flow really well. You see, it's got like a little bump on the side of it. So all we want to do is just to heat that up and let it remelt, and then.
Should we use this tip for that?
Nope, your tip is fine.
Okay.
It's a very good tip. A good general multi-purpose tip. It's actually a little wider than a lot of beginners would begin on, but that's okay. It's not good or bad or anything. What you want to do, just give it some time, give it a few seconds to kind of heat up. You want to heat everything up. All right, there you go. The other thing you want to do, if you look at the end of your tip, see it's dirty. Can you see the end of your tip? Look at the end of your tip.
Yeah.
See, it's dirty. So what you want to do is to clean your tip before you go and solder. Just jab it in there. There you go. Jab it in. Now look at your tip. Okay.
Still a little
Put
dirty.
a little solder on it. Again, the solder's got rosin. That will help you. You really probably don't need the magnifying glass for this.
I like
probably
it.
getting in the way.
Helps me see, Dad. Wait. What is... I think that's good.
That's good. Good. All right, that is good. Let's go ahead and do the other.
And we're just gonna repeat the process.
Yep.
Put a little bit of solder on there. This out of the way.
Just don't get your fingers too close. So give yourself a little more solder to use so your fingers can be a little further away. You don't want to be up right at the end.
Yeah,
You can,
I was
you can control
straightening
it. You can control it from further away. Remember, you need the board. You rotate the board to make the legs line up to make it easier. I would recommend, since your tip is like this, you orient the legs sideways like that. So you can make the best contact between everything. Give yourself some more room. End up burning the finger. Good. Another leg done. You can actually finish all the other legs.
Did a little bit of a bump. Okay, I'm gonna do this one.
Your fingers are really close to that side. You're not heating up the pad because your iron's not on the pad.
I'm trying to.
You got your iron on the resistor leg. You want to actually get it on the pad. So move it out of the way so you got room to stick your iron on the pad. Because that's where you want the solder to flow.
There.
There you go.
So, okay. We should have 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Okay.
Move the paper just in case.
Yeah, why don't you go ahead and unplug your iron for right now? Let it cool down.
Okay.
All right, so let's double check these. They look good. Really good. You should point out this one here. If you look at that one there.
Yeah,
on
it's
the
a little
end,
bit of a glob.
It's you see it's not shiny like the other ones.
Yeah.
That's generally a sign of a cold solder joint. What you want to do is heat that one back up, just let it reflow. It'll be fine. It's not bad, it's just not shiny. You won't need any more solder, but you might want to clean your iron and then melt them just a little bit just to get your solder iron with some solder on it. There you go. Now touch it.
It's
There you
not
go.
heated up yet.
Perfect.
It's still
I
not
saw it.
shiny.
I saw it melt.
It's still not shiny though.
It's okay. It's okay. It looks like it might be touching this other pad there.
Okay.
Just
Help me, please.
yep. So I'm gonna turn your soldering iron so the tip is facing away from you. You kind of went straight down on it, which
Yeah. Okay.
try to make sure it's separated.
Okay, now it's shiny. Just keep in mind, this is my first time doing this, and he's done it for at least a year or two.
Oh, I've been doing it for 30 years off and on.
That's why I said at least a year or two. What is that?
But I don't do it a whole lot until recently again. So this is desoldering braid. What I'm just going to do is going to clean that area off first. Get that extra solder off there, and then we'll kind of refill it again. It's just copper, and the solder is going to get sucked up into the copper.
Just like it does here.
And this gets the copper gets really hot when you do this process. All right.
Unplug.
No, just a second. Some flux there, which is going to help make this a little cleaner.
That's why you don't. That's why, even for beginner, even for experts, it's still not an easy job.
Okay.
You need easy amount of stuff.
I might do a few more of these so I can get a couple Q-tips out. And got some isopropyl alcohol, 99%. Spray this. Actually, it might be 91%. Just gonna clean that area, just piece on a little bit there. Just make sure it's good. Looks good.
Yep, looks good.
Sorry, get out of the way. So resistor is VCC. It's okay if the bridge is over there anyway. This actually connects to the voltage input. That'll be fine. That's where it comes in from the power supply. All right, so let's get it unplugged. So we're gonna put our next components, place our next components after you trim the legs. These are flush cutters there. Really careful with them.
Flush cutters, they are pretty sharp.
A
A little lower. Okay. You can also use these for 3D printing filament and not really much else. But they're mainly for metal and plastic, like tubing basically. But like they're for wires and.
So you just want to trim them so you kind of get to the end of where the wire is and where the solder starts, and just trim there. Doesn't have to be too far down. Just want to trim off those really thin wires, so it should be really easy to trim off. Just want to make sure not to lose those legs into the carpet below, because they can damage the vacuum cleaner belt.
That's why we have a silicone mat. Ooh, that was close. Very close to the carpet. Those are magnetic. Okay. So the legs all cleaned up. Back panel. The front with the, the
Resistors.
resistors. Thank you.
No problem. All right, so next up is the capacitors. At least that's what it says on this list. Okay. Okay, we should see a Q1
Yep.
triode.
Yep.
Okay, so this is has three legs to it, okay?
Doesn't matter how it goes
You
in.
see the shape of the
See that.
the silkscreen? You want to go in that same shape. There's three legs to it. It's a transistor. Starts with Q. And it is, there's a collector, a base, and an emitter are the three legs there.
Dad,
See?
help me.
Hang on. Let's see.
Help me put it in.
Sure.
Because I think I messed it up.
I don't think you did. I think you
I
got
think
it.
I just didn't. I couldn't put them in without bending them. I was trying to know.
It's okay. They need to be bent a little bit in order to work right. Okay. So there we go. See?
Mhm.
All right. And there should be little letters on there that say 9018 on the side, on that flat side. Let's see this.
9018. Yep.
Great. So I'm going to look up the 9018 transistor here. You know what it is. Learn a little bit about the transistor here.
Well, if Dad is doing that, I'm gonna go get my phone real quick.
Okay. So I've got up here on the screen here the info from a data sheet here on the 908 transistor. It's an NPN transistor. which is used, the package, which is the size of it, is called SOT 13, SOT 20, sorry, 23, SOT 23. It's used for AM, FM amplifiers. So that is what it is. Which, if you look up here, the transistor pin out here, like I said, there's a collector, a base, and an emitter. If you look at the package, I'm sorry, are you busy doing something?
Yeah. Trying to send my friend this option.
No, that's not it. It's not what I want to do.
Sorry, y'all. Technical difficulties wanting to send my friend something. Okay.
All right, so you'll see there's 3 legs here to this transistor: the emitter, the base, and the collector. And our silk screen actually has those labeled here, C, B, and E, right?
Mm-hmm.
You see that?
Yep.
Okay. So we just want to double check that. If you're looking at the flat side, the emitter is on the left, and the base and the collector. Yep, so that is correct. So we'll just want to flip this over. And again, we can bend these outside legs out a little bit, which help keep it from falling out. So we can solder that component in.
Yeah.
You want to lay out any more before you solder them together?
Sure.
Okay. We can certainly do that. Let's also get the electrolytic capacitors laid out.
Okay.
So, looks like we've got 4 that they gave us in the package. But we only have 3 capacitors on the part list, so they gave us an extra one.
Just in case, probably.
Yeah, so
What does MK stand for?
where do you see MK?
MK.
MK? Where do you see
Right
that?
there.
On the board?
Would that stand for anything?
I don't know.
We'll find that out later. Oh, it's probably for the microphone.
Yes, that would be the microphone. So what's the right size? Okay.
Yeah, I don't see any other capacitors. I see 1, 2, 3. I see C1, C2, and C3. It's probably just in case then. Which would make sense, but...
Now look at the diagram, I only see 3 capacitors as well.
It's probably just an extra.
So we've got a 100 microfarad, 2.2 microfarad, and a 1 microfarad. Okay. So if we look at the markings here, you'll see this one says volt 50 volts, and then 2.2 microfarad.
Okay, where are the positive and the negative? Is the positive the longer one? Which one's negative?
So the short is the negative. You'll see a negative, and the white marking there, and the dash for negative. You see that?
Yep.
Okay.
Wait, short. Okay.
Okay, and then on the back, just bend out the two legs.
Okay.
All right, and then this is the 1 microfarad. It should be labeled C3.
Now, question to clarify: is the longer one always positive? Is the longer wire for a capacitor always positive?
Always is a relative term.
Is it mostly?
I believe so.
Okay.
But it will always be marked.
Okay.
So one of them will be marked. The white stripe on that package there has a negative on it.
Yep.
You see like this one?
Yep, and I see that.
Yep. So what we're talking here is this will be marked with a negative on it. It's this white stripe. There, get this where it's this one. Okay.
So, we put the resistors in for anyone who's now watching, which, and then we've also put 2 capacitors in.
All right. So we've got 2 more capacitors here, but it only says 1.
So
Right?
we got to figure out which one is right.
And here's an example of something they kind of messed up here, which isn't a problem. So this has got a rating on the spec sheet of 100 microfarad, and you should see that C1. It says 100
Yep.
UF there. It actually included 470 microfarad 16 volt capacitors here. It's okay to overspec your capacitor. So this 470 is more than adequate to meet that 100 rating that we have. So again, make sure your negative's on the right side there.
Yep.
You'll notice the white section of the silk string that's got the lines on it is your negative side. The other side says plus for positive. And you got the capacitor all the way flush with the board before you bent the legs, right?
Yep.
Okay, good. All right, so let's solder those up. Doesn't have to be exact.
Well, that one wasn't flush. And I can't get this one to flush.
That's okay. It doesn't need to be flush.
The capacitors do though, right?
Don't have to be. It's close enough.
Yeah. Gonna wait a little bit, a second or two, or a couple seconds to solder. Gotta get
Probably want this tilted up there.
a little bit more so I can actually don't burn my hands. So let's see where we got a solder. We got a solder there, and there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 holes. Got nine things to solder. Okay. Almost.
Looks good.
Well, it's not shiny.
Fine.
Nice. Yeah, I'll have to shine this up somehow.
Oh, those are fine.
Oh, hold on. Okay.
Yep. Put a little slug around. Just wet it back up. Yep. Good.
Okay.
Okay. And your transistor there. It's great. Start playing on it. It's good. All right. You can trim those leads now.
And that's dead. Okay, so got them all soldered. Gonna trim the leads or the legs. I don't think it really matters what we call them. Whoops. Sorry. Okay. Trimming the leads or the legs. Okay. Okay.
All right.
That's what it looks like now.
Great. So next we've got the integrated circuit, which is actually lower than these other ones. So we probably should have done that before the capacitor, but it's okay. So we got our integrated circuit here, which is a CD4017BE. Which is a Texas Instruments CMOS decade counter with 10 decoded outputs. It is what's called a dip package, which means it's got these through-hole pins, and there's 16 pins. So it's a dip 16 package. Package just means the form factor for these different things, the size and how the pins are laid out and that sort of stuff. It's got 16 pins, 2 rows of 8 pins each. With dip packages, you'll notice that there's a notch in the top of the chip.
Mm-hmm.
The silk screen will also have a notch in it that's corresponds. So that's what you line up. You'll also usually see a dot, impression or a silkscreen dot or something on one of the pins, and that's on pin 1. Okay. Do you see that impression there? So that's going to line up with that. Sometimes the legs are not all straight, so you got to kind of have to gently, you don't want to break a leg off, but you got to gently get them lined up so it'll go in there. In this case, these legs are a little bit wide, so I'm just gently bending them out a little bit so get them all to line up. They appear to line up, each side lines up, so we just need to bend them together a little bit. So very gently. There we go.
And now we gotta solder them all.
That's right. Got 16 pins to solder.
Okay.
Because this is not quite so high, it's actually holding in pretty well as it is. But the other thing we're going to do, we're going to move to using this to hold your board. There's a little ledge on this vise that's for holding a circuit board.
Mm-hmm.
It got unscrewed all the way, so it's going to take a second to get closer back down to the right size. Okay, so that's going to hold it in together like that. And what you're going to want to do is to just solder one pin first. And actually, it's getting a little loose. So I'm actually going to go get some special tape I have for this very purpose. Does not have to be special tape. Some people use electrical tape or something else. For this, it's not really that critical because you're not putting a whole lot of heat on the chip itself. You're doing it on the individual pins. But what I have here is called Kapton tape. And it's a temperature resistant tape. That's really good if you need to electrically separate something that maybe has a lot of heat attached to it. It's going to be really good for that. But all I'm going to use it for is just to tape this chip down to the board. Make it easier for you to get the soldering done.
Mm-hmm.
There you go. Like I said, don't worry about the tape. Don't worry about the tape. Plug your soldering iron in. You're just going to want to get one pin over here and one pin over here.
And that'll hold it?
Down. That'll hold it for the rest of them. Okay. Cleaning your tip. A little solder on it.
Need the pan.
Pick a pin and go with that. Okay, if those look good, you can just keep going all the way right down the row with the rest of the pins. Just don't want to overdo the solder and don't want to dwell on each pin for too long. You're doing perfect.
Do I do the square one?
Yep.
What does the square one mean? What does a square mean?
Sometimes it means that it's a ground pin. But
Will you
it may not
move
have any,
this like that way?
yeah, may not have any special significance. I can take the tape off now. Turn your tip so that you're getting the flat side on the pad.
Yep, Hershey's Kisses. Nice.
Excellent. None of them bridged together. They look great.
I don't think they bridged together. This one was a little
That one's okay. It's supposed to attach.
okay. Just saying it was a little
That's
wide.
R1. That's R1 that's next to it, right?
I think so.
R3. Okay. Yeah. It's fine. They're electrically together anyway. On these legs here, these are just a little bit long.
Yeah.
Not a big deal because there's nothing next to them, but like this one's going to be a little hard otherwise. Because that hole's next to it. That's good. Looks great. Doing a great job. All right, what do we got next? Lunch. All right, lunch is not a bad answer at all, actually. Is it ready?
I think so, but
We don't have much to go. We've got the potentiometer, the microphone, got the 10 LEDs, and then the wires for voltage and ground.
how about you get a little soldering in, Dad?
So you got the potentiometer here. These have kind of cool legs that kind of hold it in correctly anyway. Once you pull it off there and stick that part in there, and let's get the microphone in. Need help with that one?
Yeah.
springy legs on that one can be difficult sometimes. Okay, potentiometer. Get the microphone here. She's got 2 wires. So push the potentiometer back in.
What does the potentiometer do?
It is a variable resistor, so allows you to change the resistance value by just turning a knob. In this case, like a screwdriver type knob. Did you say you wanted me to solder the next couple? Okay.
And that's all of
Give
them.
me a plug.
Mhm.
The next all of them. Okay. In that case, I'm gonna come around. If you're okay with it.
Mhm.
Good soldering.
Mm-hmm.
Okay.
Which one's doing now?
Next one with all the diodes. And as it tells us here, the long is the positive and the short is the negative. So one that is long is positive. So I'm just going to bend my legs out a little bit. Long is positive. Short's negative. Okay, you got 2 extras as a freebie.
Yay, we can use those for something else.
Right?
Just like Lego sets, sometimes they give you some extras.
Excuse me.
Hello.
Pizza's ready. Been ready.
Awesome.
If you're gonna have to heat it up, it's gonna be cold.
We're gonna take a break in just a minute and go get some food then. Can you be quiet, please? We're live streaming.
You're what?
Live streaming.
Oh, I didn't know that. I did not approve that.
You didn't have to. Battery's dead on that, obviously. Okay. Okay. Good. Well, we are. Show that off. We've almost got a completed board there. A couple wires to solder on. We'll be done. A switch. All right. We are at a good point to take a break and go get some food, right?
Mm-hmm.
Thank you if there's anyone watching. Otherwise, we will be back later.